Hey everybody, welcome to the last of our 3 videos in lesson 8.3 talking about altitudes and area of triangles. And we're going to be specifically focusing on the last part of that title, area. As we know already, the area of a triangle formula is 1/2 base times height. Height can be expressed as the altitude, and so as long as we are talking about the same triangle, we've already established that there are 3 different base and height combinations, or base and altitude combinations, if you'd rather call them that. So what we're going to be doing is just confirming that there are 2 different ways that we can calculate the exact same area. Okay, so we're going back to the example 2 in your lesson pages. And we're going back actually to the triangle we were using in example 1 as well, which is triangle OPQ with vertices at 0, 0, 2, 6, and 8, 0. And so you can see on the graph to the right here, one of the easiest ways, of course, to calculate your area, and I'll just trace over these in red, because this is the one that should jump out at you pretty much all the time in the examples that you're going to be given. You're going to be given one base and one height that is horizontal and vertical. So really all you have to do is count up the distance by counting the grid blocks. Okay, so the length of OQ, as you can see, is 8, and the length of the altitude is that's perpendicular to OQ is 6 units long. And so substituting that into our 1/2 base times height formula, we have 1/2 times 8 times 6, which gives us 24 square units for the area. So that, you guys, hopefully you can see gives us a target number for what we know we want the area to be using any other any other base and height combination. So in step 2, what we're doing is calculating with a different pairing. So I'll highlight which ones those are. We're using side PQ, which is going to be here in blue. And then we're using the length of the altitude to PQ. So we can use our Pythagorean Theorem to calculate the distance of the horizontal and vertical legs of that triangle that's base PQ. The run is +6, and the rise is -6 if we were calculating slope, but we don't really care about the negative so much this time, because remember, we are feeding it into Pythagorean Theorem, which is going to square each of those distances, and after that step, all of those numbers are positive, as you can see. So 6 squared is 36, plus another 6 squared is 36, equals 72. That's a rather large radical, so think back to your algebra refresher video, and what we want to do is we want to break that into 2 smaller square roots. The perfect square inside there is 36 itself, and 2, and the square root of 36 simply becomes 6, so we have 6 times the square root of 2 for that length right there, PQ. We'll call that my base. And then, of course, we're tracing along this segment here from O across to PQ, and we want to know its distance using Pythagorean Theorem. So we can go across and up, and we can count those blocks, and we have a run of 4 again, and a rise of +4 here. So we're going to square each of those in the formula for distance. 16 and 16 is 4 squared and 4 squared. Added together is 32. And inside that, as we know, we want to break it down so that we take out the largest perfect square we can. So that's square root 16 and square root 2. And as we know, that simplifies to 4 radical 2, or 4 square roots of 2. And so H is 4 radical 2 of my 1/2 base times height formula. Remember, my height is the same thing as my altitude length, and that's the distance that we just calculated. So when we substitute that in, you can see the work here is 1/2 times 6 radical 2 times 4 radical 2. And what I need you to know is because of those two square root 2's that are in that calculation, these two square root 2's together simply become 2. So they're gone, and in its place we have a factor of 2. So we'll simplify what's left. We have 1/2, we have times 6, all of this is multiplied, times the 2 that came from the radicals, and times the 4. Then we can simplify this factor of 2 divides out the denominator's factor of 2 in the 1/2, and we are back to simply 6 and 4 as our leftover factors, which guess what? That is the area that we found with our red base and height combination, which was the easy one that we could just count. And so if we've confirmed that that was the same as it was before, then we've proved our area is valid no matter what combination we use. Okay, let's go over to question number 9 and do another fresh example. Okay, going over to question 9 in our packet here. Find the area of the triangle using at least 2 different base and height combinations. And we're going to plot our points to begin with first. I'm going to do that in black. I'm going to zoom in a little bit here. Let's go ahead and make our graph a little bit easier to find. And our points are, R is -4, 5, that's right there. S is 2, 3, right here. And T is at -4, -3, right here. So you guys use your ruler, I'm going to just freestyle it here. And we have, hopefully you can see again, a very easy base, if you will, and altitude coming from S over there combination that we can count up how long each one of those are by just counting the horizontal and vertical distances. So we have 1, 2, 3, 4, 5, 6. That is my altitude in this case. And so one way of calculating our area is that 6 times the base going from R to T is 1, 2, 3, 4, 5, 6, 7, 8. And so that's times 8. And then of course don't forget it's a triangle, so we want to divide by 2. So again, we have an area of 24 square units. That's the easy one, right? So the next combination that we want to use, so a little bit of work that we need to do. If we wanted to use, let's say, TS as our next base, then we would want to make sure we know what the slope is so that we can draw in the altitude and calculate its length as well. First of all, TS, which is our base, we can calculate its length by using Pythagorean Theorem. So we have a run of 6 and another rise of 6. So that is going to be the distance there for TS is the square root of 6 squared plus another 6 squared which is again 36 and 36, which gives us the square root of 72. And that does simplify, as we know. Pull out the 36 perfect square factor, and that is going to be that base, the blue base that is going to be 6 times the square root of 2. Now, the slope of TS, when we think about rise over run, is positive 6 over positive 6, or positive 1 over 1 if you want to get really technical. And so the slope of the altitude, or the perpendicular, is the opposite, so negative, and reciprocal, so negative 1 over 1 as well. And that's from point R. So from point R, we want to make sure we're drawing our altitude down at a slope that is negative 1. And we're going to see where it contacts the side TS. You guys are going to see that gap filled in a whole lot neater than I am, because you did it with a ruler. But hopefully you're seeing that point right there, which is the point 0, 1. Now if I go ahead and calculate the length of that altitude with Pythagorean Theorem, I've got a run of 4 to go from R across to the y-axis, and then I've got a rise of negative 4. There's that slope of negative 1 that we were talking about. But again, as far as the distance goes, to figure out the altitude, that is going to be equal to the square root of 4 squared and another 4 squared, or 16 and 16, which is 32, which has that perfect square factor of 16 inside. And so I have 4 radical 2 for that altitude's length. So we're going to take that altitude and we're going to take the base, and we're going to multiply those together and confirm that we get the same area as before. So our area is 1/2 6 radical 2 times 4 radical 2, and as we know, these two radical 2's combine to just be 2, and then that 2 ends up canceling with the factor of 2 in the denominator of the 1/2, and so we pop back to 24 square units. How cool is that? All right, so you guys take a look at number 10. That's the last example that you would be needing to check out here for calculating the area using 2 different base and height combinations. Good work, guys. Keep it up.